So over here you have a car, okay? Apex Automotive would say, I think there's a myth out there that mid-engine cars are more prone to understeering, oversteering than a traditional front or rear engineered car. Is the rear engineered car referred to as a rear view? Or so you got all-wheel drive and you got rear view. So in that comparison, you can see from the back wheels to the front to so front wheel all-wheel drive or back wheels, but you can see that are these two in comparison with each other? The reason is when the mass is more centered between the front and the rear axles, the car will have a lower PMI, polar moment of inertia, and will maintain grip longer than a similar car with whose mass is less centered. What it will exhibit is a higher yaw rate, its tendency to spin in place faster than a car with a higher PMI. The car with the higher PMI will generally travel further. The car will travel further than the lower PMI. So you can see that in the middle, you can see the axle, the axle holder or whatever, and then you can see the wheels, and then you can see what this part is, the connect to the torque. So how the power is added to the wheels. So power is being transferred. Okay, when power is transferred to the wheels, but you can see that the thing that looks like a stick. So you can see how the components of a car. So if someone worked at a mechanic field or someone was a car tire changer would have more than a rough idea or understanding about wheels, or wheel alignment, or changing the wheel, or understanding about cars. And what you see is that there's some physics in it, more prone the traditional front or the reason is when the mass is more centered between the front and the rear axles. So the mass could be referred to as the size, as how big it is, to the size that, and centered means into the middle, to the center line, to the middle, between the front and the rear. So here's the front. The blue shows the front and the rear, but this will have a lower PMI, polar moment of inertia. So you have to look up what that means, okay? And will maintain grip longer than a similar car whose mass is less centered, less in the middle. What it will exhibit is a higher yaw rate, its tendency to spin in a place faster than a car with a higher PMI. So it will spin faster. What spins? Is it the wheels? Okay. Or the rate that it's spinning, as explained. The car with the higher PMI will generally travel further. I mean, travel faster or further, okay? But why a car may oversteer? For many reasons, okay? So here we see how torque works, okay? How power's at, you calculate. So this is some physics involved because of gravity and how you see the parts and the torque, and you see how this part of it. See, there's many videos that explain in YouTube context. Okay, so for us, we're going to do research on some terms here, and we can also ask. We have the power to ask ChatGPT to understand a little bit about car autonomy. Okay, how you've learned it, what you did, what steps you take in place, and you look at the lines and the numbers and the length, I guess. You can see how the wheels turn and what they do, and what is a sprocket and what they do and how they explain it and how these parts come together, and so you get a rough idea. You don't need to know too much to have some background knowledge, but at least you have more than a rough idea of what parts and how engineering works in cars. And it's engineered. You need math to make the wheel a certain size. you need math to, when you create a car model, you know, when you create the frame of the car, or the spoiler, or the bumper, the modification of a bumper, a design of a bumper. So you need some maths, because there needs to be some depth and some calculation in how it's going to be like that. Okay. So when we go back to basics, and I can describe that in shorter videos, where you have like the material of more basics and things that you need to understand to get into this, and to find where your resources are. Do those resources come from articles that you read? Do they come from YouTube videos? Yeah. So you're consuming a certain amount of time. But here, this has nothing to do with a Tuscan. A Tuscan is more to do with electricity, with how you look at the Philippine, I don't know, I forgot what they call it, but there's a Tuscan, and then you can ask questions about how the light bulb was created. But it has nothing, even though electric cars, and it's like, oh, Tuscan, maybe, I don't know. There's a lot of these things to look at, and look at the design, and you can look at kind of how animation, if you create the animation, it's like that, but it gives you an idea where that ball is. So you can see the ball that's moving, but you can see how it's rotating in that direction. So how do you get it to move in that direction? Which there's other components involved. Calculating maybe distance over time, looking at the wheels. Like when someone services a car, service the car and the wheels, and you want to look at the wheel alignment, and you want to look at the wheel if it's in good condition. If you want to see that it doesn't make a certain sound, or how it responds to when horsepower, speed, torque, strength. So it could be used in many sort of examples. Okay, someone's did TikTok, right, and they do it in TikTok context. Or they stop me and explain it in a very TikTok way, or YouTube way, and you'll start to see how they explained it and the way that they did it. Okay, so more into doing it the traditional way of presentation, because keep into a certain context until you start to kind of mix things around. But maybe through here you can see how that is moving, but what's rotating it in that direction, how that is constantly moving, perpendicular, whatever. So it's how these things shifting and how it's behaving. So yeah, we'll get more technical